video is on factored versus standard form for quadratics. Factored form is written like y equals linear factors x minus m times x minus n. When you have factored form, you have two linear factors or multiple linear factors multiplied to each other. Standard form is written like y equals ax squared plus bx plus c. One big difference is that standard form has no parentheses in it, and the exponents go in decreasing order. So we have an exponent of 2, an exponent of 1, and an exponent of 0, because x to the 0 power is in fact 1. Factored form and standard form give us multiple different pieces of information. Factored form, because of the way it is written, gives us the following info. It actually tells us if it has what the x-intercepts, roots, solutions, and zeros are. Remember, all four of these really are talking about the same thing. But because it is in factored form, we are able to figure out the x-intercepts quickly. Standard form gives us the information of the y-intercept. Because it's in standard form, we can automatically pick out the y-intercept of the problem. Now, both forms also tell us if it's a minimum or maximum, because the minimum or maximum comes from the a value in the front of the problem. Factored form will also have an a value in front of the problem. So x-intercepts, what we'll do from factored form is we'll actually set each of the factors, we'll set each factor equal to 0. What that means is that if we have x minus m as a factor, we set this equal to 0, we solve for x. When we solve for x, we'll end up getting x is equal to positive m, because we will add m to both sides. This then tells us what our x-intercept is, which we will write as a coordinate, which is that's m, 0, because the y value of an x-intercept is 0. Because what happens here, this is called the zero product property, is that if this entire value is 0, then everything is 0, because 0 times anything will give us 0. We can then do the same thing with the second factor, because it's x minus n equals 0. We can then solve for the x value to get our solution and have x equals a positive n. This is a solution. It's also a 0, and then we can rewrite this as an x-intercept or a root, which is at n, 0. Then the same thing happens from the minimum or maximum is we look at our a value, the value in front. So if we have a positive in front of our factors, this tells us it is a minimum, because the graph will open up. If we have a negative multiplied to our two factors, this tells us that we have a maximum, because the graph will open down. That's what the positive and the negative does. The positive makes the graph open up, and the negative makes the graph open down. So if we're looking at standard form, written as y equals ax squared plus bx plus c, we can automatically find the y-intercept. The y-intercept is actually the c value of the problem, the constant. The c value is the y-intercept. This holds true for slope-intercept form as well, because you have the constant value of y equals mx plus b. Your constant was your y-intercept. So in the form of standard form for quadratics, your constant is your y-intercept. This means that we can write our y-intercept as 0, whatever the c value happens to be. It tells us if it's a minimum or maximum the same way it did for factored form. If the leading coefficient, the a value, if we have a positive ax squared, then we have a minimum. Again, because the a value is positive, it's going to open up. If there is a negative ax squared, that tells us that we will have a maximum, because the graph is opening down. Factored form and standard form give us our intercepts. We need to have it in factored form to find our x-intercept, and we need to have it in standard form to have our y-intercept. We'll need to be able to get from one form to the other and vice versa so we can find all of the intercepts. So to get into the forms, to get into factored form, we would take our standard form and factor the original completely. We always look for our GCF first. No matter what, we always need to factor our GCF. Then we determine how many terms remain after we factor the GCF. If there are only 2 terms left over, we do what's called the difference of squares. If there are 3 terms left over, we do guess and check, or we factor it any way we can. This is just a guide to know some reasons or some ways to factor. So sometimes you cannot do a difference of squares, and that's okay. But if it's 2 terms that are remaining, we do want to try and factor out a difference of squares. That's what we look for. If there are 3 terms remaining, we try to write them out. We try to factor using guess and check, MACAB, the AC method, any method that you've learned to factor. But we must always rewrite it as y equals again. So we always want to take the original form and change it. We're manipulating it into a different form, but it's still a y equals. So to get into standard form, we do what's called distribute the factors, or use the box to multiply. We're just going to distribute it so that we have no parentheses remaining. We want to distribute all parts of it so there are no parentheses. So we cannot forget to distribute the a value, and there will be no parentheses any longer. And again, we're going to rewrite it as y equals. So to do a couple of examples, on this first example, we're going to rewrite the following into factored form. Then we're going to tell what the x-intercepts, the y-intercept, and if it's a max or a min. So some of the information we can automatically figure out based off of the original problem. The original problem is in standard form because there are no parentheses in here, and it goes in descending order with your exponents. You have x squared, x to the first, and then no x. So this is standard form. This problem can automatically tell us what our y-intercept is because it is in standard form. Our y-intercept still comes from our c value. So that's going to be our 24. So we can actually go ahead and say that our y-intercept is at 0, 24. And we can determine if our quadratic is going to open up or down based off of the value in the front, our ax squared. Since our a value is positive, we can actually determine that it's going to be a minimum because the graph will open up. So in order to find, we've already found if it's a max or min and the y-intercept, we need to determine the x-intercepts, and we need to rewrite the problem into factored form. So to rewrite into factored form says to factor the original problem completely. We need to find the greatest common factor first. So we look at all of our terms. The smallest number is 2. All values, 14 and 24, can be divided by 2. So I know that my GCF includes the value of 2. Then I look to see, do all of my terms have the letter x, or the variable x? A does, B does, but C does not. Therefore, my GCF is only 2. I must factor out that 2 by dividing everything by 2. I'm left with y equals, since we factored out that 2 is on the outside because remember, factoring is just the opposite of multiplication. We're dividing it. I'm left with x squared, positive 1x squared, positive 7x, and positive 12. So I keep it written like this because I know that if I multiplied the 2 back into the parentheses, I'd get my original. Now I want to factor this trinomial. There are 3 terms, so I'm going to use guess and check. So to use guess and check, I'm going to factor out my x squared is x times x, and then I'm going to do my 12 as well. I know that 12 is 1 times 12, 2 times 6, and 3 times 4. So now I'm going to guess which numbers go together, and then I'm going to check to see if it works. So I know my value of 2 is on the outside of my parentheses. I'm going to put an x into the front of both, because I know that x times x gives me x squared. Then I'm going to put in the back my back numbers. So I'll try 3 times 4. I'll have a 3 and a 4. And then I'm going to check to see if it works. So I have 3 times x is 3x, and x times 4 is 4x. 3x and 4x will give me 7x. So I know that my values here are in fact correct. So I know I can have a positive 3 and a positive 4. So I'll have x plus 3 and x plus 4. So if I were to rewrite this, I would rewrite this as y equals 2 parentheses x plus 3, close parentheses, parentheses, x plus 4. So my two linear factors are x plus 3 and x plus 4. That allows me to find my x-intercepts. My x-intercepts come from our linear factors. That's the x plus 3, and I set that linear factor equal to 0. And I take my other one of x plus 4, and I set that equal to 0. Then I'll solve them. So my x-intercepts are at negative 3, 0, because I solve for x here. I know that I subtract 3 from both sides. And my other x-intercept, if I solve for this one, I'll subtract the 4, I'll have at negative 4, 0. So my x-intercepts are at negative 3, 0, and negative 4, 0. I have my y-intercept at 0, 24. I know it's a minimum. Again, the minimum is because the a value is equal to a positive 2 from the original. So I know that that's going to be a minimum. Therefore, I have my entire problem rewritten so I can find all pieces of information. I was able to find 2 pieces before I even factored it. So you always want to determine what information can you find before you do anything to the problem. On the second example, we're going to rewrite the following into standard form. We're also going to tell what the x-intercepts are, the y-intercept, and if it's a match or a min. So before we rewrite the problem, we determine that this is in factored form because we have 2 linear factors multiplied to each other, and I can determine the x-intercepts from that. So before we do anything to it, we take our x-intercepts, come from our linear factor of x plus 1, and we set that equal to 0, and our second linear factor of x minus 3, and we set that equal to 0. We can also determine if it's a max or a min based off of the value in front. We have a negative 2 times your parentheses. That tells us that the a value is in fact a negative 2. So before we even do any of the problem to put it into standard form, we can already determine the x-intercepts and if it's a max or a minimum. So now we still got to find the y-intercept and to rewrite into standard form. The y-intercept comes from when you have your c value, it's 0, c. That's why we want to put it into standard form so we can find our c value. So what we're going to do is rewrite this by distributing the factors or using the box method to multiply. When you distribute, you can multiply any 2 things at a time. So we can distribute our a value into either one of these, only one of them, or we can distribute our parentheses into our other parentheses. I'll do this problem by distributing the a value into only the first set of parentheses, because it's only negative 2 times this first piece. It's not multiplied to both. So I'll end up with parentheses. I'm going to keep it in parentheses because my second set is still there. I have not touched that second set. I'll have negative 2 times x is negative 2x, and negative 2 times positive 1 is negative 2. We still have that x minus 3 that we have not touched. We still have the y equals. Now to continue, we want to get rid of all the parentheses by taking everything in our first set of parentheses and multiplying it into our second set. So everything gets multiplied. So we're going to take this negative 2x and we're going to multiply it to the x and to that negative 3. So when we multiply that, we'll have y equals negative 2x times x is negative 2x squared with no parentheses because we are distributing all throughout the parentheses. And then we have negative 2x times negative 3, which is a positive 6x. So we've multiplied the negative 2x to everything, but we still need to multiply that negative 2 to everything. So now I'll take this negative 2 and multiply it to the x and to the negative 3. So negative 2 times x is negative 2x, and negative 2 times negative 3 is positive 6. Now that we've distributed everything, we can combine our like terms to make it into standard form. So we will combine our positive 6x and our negative 2x. These two pieces can combine, and we'll end up with y equals negative 2x squared plus 4x plus 6. This is now in standard form because we have no parentheses and our exponents are in decreasing order. Now that it is in standard form, we can find our y-intercept from our c value. So our x-intercepts are, and they came from the factor form from the original, when we had the x plus 1 equals 0. So our first x-intercept is at negative 1 comma 0, because we subtract the 1. And the second x-intercept is at positive 3 comma 0, because we have to add 3 to get the x by itself to find the solution. Our y-intercept, now that it is in standard form, it comes from our c value of standard form, which is 6, so our y-intercept is 0 comma 6. We also know that our a value was a negative, so that means that we have a maximum vertex. Our quadratic would have a maximum. This is how we go from one form into another, and we use both forms to find all of our pieces of information.